about Docker and Kubernetes. So this is really important. It's not covered in any of our classes. It should be part of the cloud curriculum. And I've learned a lot here, and I found some really good tutorials to follow. So like I said, it's probably going to be a whole course, and this will be the first few projects in a new course. So anyway, that's what I'm planning to do, is demonstrate this stuff tonight. So what you need to, the first thing is, for most of this, you got to be on 64-bit Linux. Now, technically, Windows claims it supports Docker, but I've never tried that, and that's not what most people do. So I'm not going to waste my time on that. I'm going to do it on Linux, although it can be an ARM-based Linux. So let me get my correct Docker machine up, or correct Debian machine up. This is the one I use for other purposes. I don't want that one. I got one I use for Kubernetes. All right, there we are. And so I'm using Debian 12. I'm using a headless server. You can have one with graphics if you prefer, but I prefer a headless one. And I'm running on ARM. You can run on any operating system. It doesn't matter. 121, 152. Let me see if I can connect. Okay. All right, got to get out of that. (192). Okay. All right. Good. So there's my headless server. All right. And I was very pleased to get this stuff written because I've never quite understood Docker. And now I understand it a whole lot better. So here's the deal. Docker is a substitute for virtual machines. We're all used to using virtual machines, but virtual machines, as you know, are very big and they demand a lot of resources. Like if you run 2 virtual machines on a laptop, that's usually all you can run. Each one of them takes a whole bunch of RAM and a whole bunch of processor, and that's because they emulate all the hardware. So you have an SSD, but they emulate a hard drive. You have a network card, and they emulate another one. You have a processor, and sometimes they emulate a different one, and so on. They're working real hard to simulate an entire hardware environment. And the point is, you don't usually need all that isolation. You could use a lot of the hardware and the software on the host, and that's what Docker does. What Docker does is it runs a thing called OverlayFS, which is a file system that puts another layer of files on top of the existing file system. So if you need to have a file in your container, which is what they call effectively a virtual machine, and that file exists on the host, it doesn't make another copy of it. It just connects to the file on the host. So if you make a Docker image of Linux on a Linux host, it's almost size 0. It's really just a folder that reuses the files on the host in most cases.
So this is something that you add next to the virtual machine then?
Well, you do it instead of virtual machines.
Instead of?
Yeah, that's the idea. So these things are called containers. A container is a unit of software that runs an application. And see, this serves another purpose. Another purpose of Docker is to solve this problem that you probably found. If you download something that uses, say, Python, and try to run it, it never works because it doesn't have the right version of Python and the right version of all the libraries. And so you really would like to package all the right versions of all the dependencies in with your app. And when you install Linux apps, they never have all the dependencies, and you have to hunt for the dependencies, and they're the wrong version. But if you use Docker, you make an image that includes all the right version of everything. And it will run efficiently because it will only download new files if it has to. It will use the existing files if they are the right version. Otherwise, it'll add them, and in the container, you'll have that application running. That's the idea, is to make applications portable and to make applications run with all their dependencies satisfied without having to statically compile everything. That's the old way. The old way is to statically compile so every program has a copy of every library function it needs. And then you end up with multiple copies of them running on a machine. It makes your executable very big, but then it's independent.
But if I understand correctly, this increasing portability
Yeah.
decreases the isolation.
Yes.
So I can do malware analysis, for example, with Docker.
Yeah, well, what was that?
I would not, it would not be advisable to do malware analysis
Well,
with Docker.
that's exactly what people argue about. And like I say, I've never used Windows Dockers, but the idea is they're less safe. They are less isolated from the host, especially if you share a folder with the host, which is commonly done. So that's the thing. But the thing about them is they are much, and they're much, much smaller. So if you go to, say, the Web Security Academy, which you guys have done probably in other courses. You go there, you click a button, and it takes a couple of minutes, and then you have an app to attack. It's spinning up a container just for you. So a server that could only run, maybe 5 or 10 virtual machines can run like 100 or 1,000 Docker images. So it's so cheap, you can have every student spin up their own Docker image. And so that's the idea. So that's what a container is. Docker is the most popular container runtime. There are some others that do this. And a container image is a piece of software that contains everything needed to run an application. And we're going to make a container image pretty soon. It is extremely easy. So here's the rules. It's not too demanding. You got to have 2 CPUs or 4 gigs of memory and 20 gigs of space, which is not much even for a virtual machine. And then you can just install Docker. So here's, and this is something great. Last time I wrote Docker projects a few years ago, you had to always run them as root. And they kept saying, we really are sorry about this. This is really bad for security. We'll fix it someday. Well, they finally fixed it. Now you can run it. You make a special account called Docker, and you can run it as this non-root user Docker, which is much better. So I've already got it installed on this machine. Here's so I can do this one here to get the status of Docker. All right, and so it's telling me here, up here, enabled, active, running, all sorts of good things. That's what I want to see. My Docker appears to be okay. All right, hit Q to get out of there. So now, we're going to run a Hello World container. You can run a container, and what it will do is it will go to the, now let me explain this while I'm here. There's a thing called Docker Hub. And this is like, when you do apt-get in Linux, it downloads from these Linux repositories, all this software. That's what Docker Hub is. Docker Hub is where all these images for all these machines are, for all the normal ones. So you can just download them and they'll automatically come from here. And you can search for them here. So we're about to run one called Hello World, and you can search here for Hello World. And you'll find the Hello World image. And you see it's been, it'll tell you about it. It's, here's the example. You can run a Hello World. All this is going to do is print out a message and then stop, saying hello. And here you can see how it works. And it'll show you where it lives. It lives on GitHub. And the way I found is to go to where to get help. No. There's a way to get to the GitHub from here. Where to file issues. This will get you into the GitHub. Now you can go Hello World, and you can see what it is, and it has versions of it for all the different processors like ARM and so on. Here it has the source code for the Hello World app, which is just a C program that just prints out a message. That's all it does. And you can see the Docker file. So let me run it, and we'll come back and look at the Docker file there. So to run it, you just do docker run hello world. All right. And now, I've already downloaded it. If you haven't downloaded it, it'll say, I need to download it, and download, and then run. And this one, when it runs, it just prints out this message and then stops. That's all. Now you can see your containers with Docker PS. This shows you your running containers. And I've got a bunch running from before. I'm going to clean everything off. Which is, well, I know I'm going to do Docker remove. Let's do Docker help. Okay, there's remove or RM. Yeah, Docker RM. Okay, Docker. Okay, PS will show me my running containers. I'm going to stop this one. We'll get to it later. So I'm going to stop this container here, which is this one. And I got to spell Docker right. Okay. Now that I've stopped it, yes. Okay, now I can remove it. It won't let you remove a running container. All right, now if I do Docker PS, it shows me no containers, but these are running containers. If I want to see them all, I do -A. And now I see, here's my Hello World container. And here's an old one left over from before. I'm going to get rid of this one. Get this container ID and Docker remove. Got to spell Docker right. Okay, remove that one. Okay, now, here's where I'd like to be. Docker PS -A. I only have one container. It's the Hello World container. Now, I could have specified a name for this container. when I created it, but if I don't, it will make up a name, which is some nonsense like that, just a couple of words stuck together. So you can refer to it by that name. It would probably be a whole lot more professional to specify the name when I create it. So it'll have a name that means something to me, but I have a Docker container, it's not running. Because this container, when you run it, it prints something and then stops automatically. It is not intended to just keep running. It's just a Hello World application. All right, so that we're...
Docker PS just lists all the image that you download?
Docker PS shows you your running containers. Docker PS -A shows you running and stopped containers. But images are something different. Images are all the things you've downloaded.
But your Docker, you run it and then it should stop, right?
This one stops, that's right, so it's not running anymore.
So why is it still so up in Docker PS?
Because of the -A. The -A is show all of them running and stopped. So if you do it without the -A, it won't show up, because this is only the running ones. So that's real important. All right. Now, also, you mentioned images. I have a lot of images. The images are still there. That's why I didn't have to download it again. The containers are gone, but I haven't cleared out the images. So everything I downloaded ever on this machine is still there. And they can get kind of big, so you might want to clear that.
In the memory or something?
Yeah, well, they're stored in a special folder. In fact, let me see, Docker list images. I forget how to do it, but we'll find it. There, Docker images, okay? Docker images. There we are. See, I have a lot of them, because I've done a lot of projects here. Here's the Hello World, and here you can see how big they are. And see, some of them are actually pretty big. This one here is 1 gig. These are basically what you'd think of like the virtual machine. They're all much smaller than a corresponding virtual machine, but some of them get pretty big. So you might want to clear out your images. In fact, I wonder how to delete the images. Let me see, Docker delete all images. I'd like to do that to get, how can I delete all images? And there is a nice way to do it.
But forgive me,
Yeah.
so the image would be the equivalent of the OVC file that
Yeah.
we imported.
Yeah, it is like that, yeah. And it's Docker,
So that's why it becomes heavy, large.
yeah, and I think it's Docker system prune, that's it. Docker system prune is the simplest way to clean up. System prune. This will stop all dangling images, yeah. Now, I don't think it gets rid of all images yet. Right, that's what I still haven't. Now, there is a way to get rid of all images, which is -A minus volumes. Let's try that. I've never used this one, but I think it's what I want, minus volumes. Yeah, get rid of all images, yeah. There we go. Bunch of stuff got deleted. Now, if I do Docker images, they're all gone. There we go. That's what I want. Now I have a nice clean box. And you might well have to do this after a while, because they can get big and start filling up your hard drive. So that was Hello World, which gets us started. All right, and now if I go back to my instructions here, all right, instructions are here. There we go. So we can now see the Docker file for this image, and I was nearly there. If you go here, and now I'm running on ARM 64 actually, so I think I'll be in here, and here's the Docker file, and that's it, 3 lines. That's why it's so small. What this does, from scratch, means without anything, with not copying any files from the host at all, copy this one file called hello to the root, and then run that file. That's all it does. And that hello is compiled from that C code, and it's statically compiled, so it includes the executable and all the libraries that are required. That's it. That's why I say this container does nothing except run that one application and stop. It doesn't even have a whole operating system or anything in there. So it's really incredibly simple. And that's why Docker containers are so small.
For what type of work, for
Yeah.
what type of projects would you suggest to use this Kubernetes?
Well, it'd be good for anything Python. It requires libraries, and there are Python containers, and typically you see it running Linux, like Apache and Nginx and stuff, but anything you'd run on Linux, you could run in Docker, and pretty soon you'll think you should, because otherwise it'll keep breaking because it'll have the wrong versions of libraries after a while. And you have this endless, this is basically the answer to the endless dependency problem of Linux, where you run something, but you can't find the right versions of junk. This is the way to do it. Of course, there are serious security implications. That means you're always using old versions of stuff, which are probably vulnerable. And right, and that's why, you can argue. But anyway, to get something done, it's really fast. And I can see why people don't worry. I'm always trying to clean up containers. People say, don't bother. I see why. The container is pretty small. The Docker file is just a few lines. And, all right, anyway, so that's why I thought this is pretty awesome. Now that I see it.
Docker is only run it once, right?
Yeah.
I mean, you just run it once and then stop. Even though it contains all the vulnerability with the image, but then it only one
Well,
and stop.
but usually you leave them running. Usually you run something like a server on Docker. And the reason you do it is so you can run a whole cluster of servers. So if one crashes, the other can take over. And you leave them running all the time. So it would matter if you're running vulnerable versions. That's why, that's the problem with distributing things that way. But anyway, here's what it says. From scratch means just use the host kernel, don't add any new files, copy the XL and execute the hello. So that's what happens here. So now, let's get some information about the host system here. Uname minus R rather. Okay, this is ARM64 6.1 kernel. And now if I do ps aux, it's going to be too long, so I'm going to do head minus n10. All right, there's the first 10 processes. There's a lot of processes running on this machine, of course. If I just do ps aux, then it's got them down to 36,000, tons and tons of processes, because it's a whole operating system. Even though it's headless with no graphics, it's still pretty big and complicated. But if we run a container, it's going to be a lot smaller. So now we're going to run BusyBox. And the only thing we're going to change is to add the -it. That means interactive. So if we run that, it can't find it locally because I deleted all my images, so it's going to download it from Docker Hub. And there it goes. Okay, it's done. And now here I am inside the container with a pound. Now if I do the same stuff, uname minus R, it's the same kernel because that's the whole point of Docker. It's using my host kernel. It didn't make a separate copy of the kernel. It's running right on my host kernel. Now, if you do ps aux, it's only got 2 processes running, as opposed to the host that had all this junk running, because it's much simpler. It's a stripped-down Linux environment with a kernel, but almost nothing else. And so I can exit from here, and I can now look at Docker ps, and I'll see it's not running anymore, because when I exited, it stopped. And if I do the -a, there it is. BusyBox is here, and it created 49 seconds ago and exited 10 seconds ago. So it has stopped. Now, if I don't, okay, so here's the explaining all that. All right, so now I might want to exit without stopping the container. Now notice my container has a name here, this ridiculous name. Let me make my window a little smaller so I can easily copy it. Okay, Xenodochio Bihaba, whatever the heck that is. There's the automatically generated name, which I say is why you'd probably rather specify the name in your command line. In fact, let's try that. Let's do docker remove this thing. All right, now I'm going to do docker run, and I'm going to give, I think it's dash name. Might be dash name. Okay, let's try something else. You can docker run help. This is how you get help, which is really important. Docker help gives you the basic commands, and since I know I want to docker run, I can do docker run help. Okay, and now I think it's name. Maybe not. Name string. There, dash name. Okay, so that's what I thought. So instead of doing this run, I want to do dash name. I'm going to call it BB1. There, a much simpler name. There, now I'm in. Now I exit. Now I do docker ps, and it's not there because it's not running. But if I do -a, there it is, and now it has a nice short name, BB1. I feel happier about it. So here's the one I created, but it stopped. So I'm going to start it now. Docker container start BB1. Okay, now it should be started. Now it shows up here. So it's running, and now to interact with it, I can do exec to execute a command interactively, and the command is sh to open a shell. So it's going to be docker exec minus interactively BB1 and sh for shell. And now I'm in. And now I can see what's in here, and you'll see it has all these files, but remember, and print working directory, there, but they're on the host. They're another copy of files from mostly. Most of these are just empty folders. That's why the whole thing is really small and really fast. All right, so now if you want to exit the container without stopping it, you use Control P, Control Q. Otherwise, when I exit, it will stop. So Control P, Control Q. Now I'm out, and the container is still running in the background, which is typically what you want to do for a server, like a web server or a database server or something.
Forgive me, which
Yeah.
was the command to completely stop?
To do what?
To completely stop the
Just Docker stop.
Docker stop.
Yep, just like Docker start. Yep, Docker stop. So I can do Docker stop BB1, and it'll take a little while to shut down, and then it'll print some kind of identifying number here.
So, I didn't remember the command.
Okay, and just the name. And so now if I do Docker PS, it's not there, but it's still around. I could start it again. It's in my stopped containers. So that's good. All right. All right, so now I can delete it, like I said, stop it, and I could just do Docker delete, or I could do Docker system prune. I guess I'll do Docker system prune. Say that'll delete all stopped containers, among other things. So that should do it. Now if I do Docker PS -A, I have nothing. Okay, so now I'm going to run an echo server. So here's somebody's echo server, and I'm going to just copy this part. I'm going to do Docker run, and I'm going to give it a name, echo1, there. Okay, and like it has to download it, and this is what it looks like. It's not too big. There we go, and it's done, and now it's listening on port 80. And now I think it's not giving me, it doesn't give me a command prompt because it's running, by default, it runs in attached mode. Standard in, standard out, and standard error are connected to the Docker machine. So the problem is, what I started here was a web server, which does not interact with the terminal. So now my terminal is frozen. So that's annoying. So I'm going to have to press.
Can you get the browser to look at that?
Yes, I could. The problem is all Docker containers are running in a private network you can't get to. You have to run a forwarder to get to them.
Does the host see the Docker machine?
No, but if I had graphics on the Linux, I could maybe see it. But Docker's run in an internal network. And in fact, this is a good question. Let me exit from here. Control C should.
Your host machine sees the Docker machine, right?
There's a special network made for it. In fact, let me see how we're going to do this. Let me open a second terminal. That's the way to do this. Okay. These are very good questions. Okay, now it's 192, 192, 168.
You can also use a text-based browser too, right?
Yes, like curl. Yes, you could. Yes, and we'll do that like that in a minute. Okay, now, if I come in with another terminal, that's still running. Now I can do Docker PS. Okay, and there it is. It's running. And I can do sudo ss -panel to see listening ports. And you'll see the container is listening on this port. That's part of Docker, but you're not going to see it listening anywhere yet. We're going to have to do some steps to make it visible. It listens, but the networking is all hidden. You have to use more commands to publish the network so you can see it. So now I can stop it from here, from the other terminal. This terminal is still frozen. It's not listening to me because the web server doesn't listen to the keyboard. So I have to stop it from another terminal, Docker stop BB1. No, whatever it was. This name. It's called echo1. All right, that should have unfrozen this terminal. Okay, now, what we're going to do now, we've stopped it. So now, this is how you publish the web server. This is going to take port 80 on the local container and list and forward port 8080 from the host to it. Now I'll be able to see what's in there. That's the one. So here I give it a name. I'm going to run in detached mode so it doesn't lock my terminal. I'm going to publish the port so I can see it. I'm going to just specify the name, and that's it. That's all I'm going to change about running it. So this is a better way to do it. So I go here. Let's minimize one of these. We only need one of these right now. All right. And we don't need it. Probably don't need it so wide right now. All right, so there we go. That's going to run it, and it just gives me some kind of identifying number. Now it should be running. If I do Docker PS, there it is. It's status up for 6 seconds, so it's running. All right, and if you do this, let me make this a little narrow so it wraps there. And here's the ports. Local port 8080 is going to 80 inside the container. So now, if I do sudo ss minus pantel, now I'll see listening on port 8080 is Docker proxy. And now I can do curl localhost 8080, and it should reply by showing me something. Now, I've seen this happen before where it fails. And as far as I can tell, you have to restart when this happens. There might be some better solution, but the curl should have replied back my request, and it didn't. And so I think I just need to restart the machine, which tends to happen. So I'm going to give it Control-C and exit. And, oh, I closed the other window. All right, so I'll just do it here. We're going to get to my virtual machine. Okay, and I'm going to do sudo reboot. And give it a password. There. I had to do this before when the curl won't work. Something about the networking tends to foul up. By the way, it's really new and it has a lot of bugs. And what's amazing is people have been using it for a while because it saves so much money. Everybody's rushing to use it, even though it's not really a finished product. They've recently got a certification, though, which is what the tutorial is for. There's now a certification for Kubernetes, which is what we want. And so it's getting to the point where it's worth teaching and learning. But it's been constantly changing really fast. It's a new thing. But it's good to know about it. Everybody's using it like crazy now. So now I'm back in. So now let's see if the container's still running. I think it's not going to be running. Nope. How about -A? Well, it's still there. Echo 1. Echo serve 1 is the one I want. So I should be able to start it. Docker start echo serve 1. Now sudo ss minus pantel Debian. Okay, now here it is listing again in 80. I might be able to do it now. Curl localhost 8080. Yeah, now it works. So it's running an echo server. You can send it a request and it will just return the request back to you. So I should be able, for example, to use netcat. And I should be able to say hello. And bad request. Okay, I guess you have to have a good request and it'll send it back. Anyway, so if you send it a web request, it'll echo it back to you. That's all it does. Now, let me get rid of this and let's get back to my instructions. All right, so we've done all that, and now you can look inside the running echo server. You can execute a shell inside there to see what's in there. So we did this. On the outside we looked, and it's listening on 8080. We can look inside with Docker exec -it, and the name of the thing is echo serve 1, and I'm going to run a shell. So now I'm in. Now I can do ls -l and see I'm in a directory called root, and it's a JSON web server. That's what they chose to implement here. They could have used Apache or Nginx, but what they did was they wrote a file in JSON to do this echoing thing. And I can do netstat. By the way, I don't have SS. A lot of commands are missing. Like most minimal Linux environments, they don't put on any extra commands. So often when you try to use a familiar command, it's not there. But I did have netstat. So I can do netstat -pant. And that'll show me this is listening on port 80. A process called node is listening on 80, but on the host, a process called proxy is listening on 8080. That's how it works. So this is the exposed process on the host, and it forwards traffic to this other process on the container. That's how you get to it. So that's something to get used to, and we're going to see a lot more of this. We're going to have like 2 layers of networking we have to dig out of when we get to Kubernetes. And so now we can clean everything. Let's do Docker PS. It's running, so let's stop it. It's called EchoServe1, so I can Docker stop EchoServe1. Okay, and now I can do Docker PS-A. And see, I have a couple of containers. I can nuke them with Docker system prune. And yes, and now I have no more containers. So my machine is more or less clean, although I still have some images. They won't have to re-download the images, but I don't really care about that. So, like I say, I had to do a reboot before any web server. We'll see what happens here. Now I'm going to run Nginx, a popular web server like Apache. I'm going to give it the name Web Server 1, again publish 8080 to 80, and run it in detached mode. So this should run a web server. And since I deleted my images, it's going to have to download the Nginx, which is bigger. So it'll take a little while to download the files for Nginx. All right, didn't take too long. Let's see if it's running. It is running. Okay, and I told it to publish 8080 to 80. So if I do sudo ss-panel, I'll see it listing on 8080 again. That's good. So I should be able to curl, local curl, that is, local host 8080. I think I might need a colon. I do need the colon. Okay. There, now it works. Now I get the default welcome to Nginx page. So the web server is running, and in fact, up here, it was listening on 0000, so I'll even be able to see that on a public IP address. And if I do IPA, you'll see I've got the loopback address, and I have the normal interface that goes to the internet here. And now I have some new interfaces like Docker. That's for that. It has a separate network, 172.17, that it's using for that. That's why it's listening. Every container has its own IP address inside its own subnet, behind sort of like a virtual router, just like VMware does. Yeah. And so now I should be able to view this on the outside. If I go out here and go to HTTP and that number and then 8080, I should see the Nginx welcome page. So it is this web server, and I've exposed it to the world by using that, by specifying this publish command. All right. And so now we're going to put a custom web page inside the container. So right now it's just the default web page it's serving. In fact, I'll just leave that there. Okay, so now let's go in the container, which is there. Docker exec -IT for interactively executing, then web server, and a tab completion works, and sh will give me a shell in there. So now I'm in the container. Oops, I didn't use a T there. Uh-oh. Something bad happened. Let's see if I killed my container. Docker PS. Well, it's still running. Okay, let me try again. Docker exec -IT. I don't know what I without the T does. Something bad. Okay, now I'm in. Now I can do pwd. So I'm at root. ls shows the usual stuff. So the user share nginx HTML is where the files are. So I can do it. I can look in there. Users, this is where Nginx stores files, at least in this container. So I can look in there, and there's an index.html, and this is the error message for like 500 type errors. So I can change that index, like here, I can echo inside the container into that file. That'll put different contents in that file, and now I can exit. And now if I just refresh it here, it now says inside the container. So I've customized the web page. That's one, and I could do it with curl too, of course. There, now it says inside the container. So I could have a web server in a container, and I could update the container by constantly changing the contents of the container. But that would be a drag, because the whole point of this thing is to run a cluster of servers, of containers, typically on a cloud service like Amazon or Google Cloud, and you'll have like 5 or 10 of them, and you'll have it automatically scale, so when there's more traffic, it will spin up more servers and automatically go down. So it's constantly creating new containers. And if you had to put all your web content inside the container, it'd be making all these unnecessary extra copies of it. So what you do is you connect it to a folder on the host, and it fetches the data from there. You only need one copy of the data, even if you have many servers sharing, many containers sharing it. So that's what we're going to do. So we're going to mount a volume, they call it. And so first I'm going to make a volume. So I'm just pwd, here I am in my home Debian, it doesn't matter, like that'll do as well as anywhere else. So I'm just going to make a directory. I probably already have one from doing it before. Yeah, I made a directory called HTML here. And if I look in there, I put a file called index.html, and if I look in that file, it just says outside on host system. I just put a file there so we can see it. Now I'm just going to make my Docker machine go there, and I can stop it and rerun it under different conditions, but it's going to be a different container now. So first I'm going to stop the old one. Okay, now if I do Docker PS, it's gone. If I do -A, it's still there, but it's not running. But now I'm going to make a new container, because if you want to change the parameters, you have to make a new container. I don't think you can change the parameters on your old container. So Docker run is what creates it. So it's going to be detach. Here's the volume. Home address HTML, that folder is going to go to user share nginx HTML. That's what connects the two folders together. This connects the two web ports together, 80 in the container to 8080 on the host. I give it a name of web server 2, and nginx is what specifies the container. I'm getting this one from Docker Hub, which is the one they give you that runs nginx. So that's the command to start it. It starts right away because it doesn't need to download nginx. It's already got it. It just basically makes a folder with a couple files in it. Now I can run Docker PS, and it's running. And now if I curl, I get on host system. And if I go here in the web browser, I'm on the host system. So now the web server is serving files from my host. And this is very common, like I say, because the engine that delivers it would logically want to be separated from the file server that hosts the files. You'd want to be able to put those in different places. All right, because they have different requirements for replication and all that jazz. So now let's run a MySQL container. I think I'm going to get rid of the web server first. I just sort of like to clean things up. Let's stop it. Web server 2. All right, and then I'm going to prune, system prune. Just like to keep things clean. There, now if I do Docker PS -A, it's all gone. I have a nice clean environment. All right, so now we're going to run MySQL. Now that's going to listen on port 3306. I'm going to give it a name of DB1, and I'm going to run it in detached mode. So it'll offer a MySQL server. All right. Once again, it has to download that.
I assume the alternative to detach is attach.
Yeah, default is attached. And then what will happen is your keyboard and your monitor will be attached to it. So if it doesn't interact, it'll freeze on you. Yeah. And by the way, I think they spelled detach wrong. Isn't it supposed to have a T before the C? Anyway.
No.
Okay, good. Then it's just me. Glad to hear it. Because I know in web headers, they misspelled referrer, and we're having to misspell it forever because that is the rule. This happens sometimes. People spell specifications with something spelled wrong, and we have to keep spelling it wrong forever.
There is where did I find a time that was funny? Was the switch? I think it was peacock. Instead of spelling peacock EA, it was spelled AE.
Yeah, you're right. Detach. Okay. I thought there was a T in it. DTATCH. Oh, I guess you're right. Yeah, okay, good. They spelled it right and I'm wrong. Well, that's better. Okay. All right. So now this thing is still downloading. Okay. Good. That was annoying me today.
Catch as a T.
As I wrote up this project, I was thinking, all right. So, okay, now I can do Docker PS. And it's not there. It's not running. And it's not listening. Okay, so something is wrong. All right. Now, let's find out what's wrong. Let's look at the container here. Here's the Docker Hub explaining about MySQL. All right, and so here's information for it, where to file issues, supported architectures, how to use this image. Notice you have to have an environment variable. You have to give it a root password or it won't run. So that's what is missing. I didn't read the instructions. This is how you do it. So that's the problem. So let's fix that. Here --env is the long version of that switch, which I like using the long version so I can remember them. So now I'm going to use this, my secret password, as the password. Now I'm ready. Nothing else has changed. But I'll remove the old one, Docker, remove db1. All right, now I'm going to run it with a master password. It refuses to run without the master password. Okay, now, if I do docker ps, it's running. And if I do ss-panel, it's listening on 3306, Docker proxy. So it's working now. All right. And that's it for this one. So I'm going to stop this video. We have a separate video for each project. That gets you started with some fun with Docker. Let me stop this one.